metrics that are directly related to the available how they work. So because of this nature of the market, where these values are galaxy in this, that could be can be avoided and making better control over time. And in reality, each cycle is different, has different power.
Also on the contractual side, one thing I see that there's two possible root causes.
Hello everyone, and welcome back to Sinovoltaics webinar series in 2026. My name is Rasa Jakaitis. I'm media manager at Sinovoltaics, and I will be moderating today's webinar on best performance forecasting and operational reality. Yesterday, Benchmark Mineral Intelligence announced that 2026 is expected to be another strong year for battery energy storage, with forecast additions exceeding 450 gigawatt hours. Energy storage project development is clearly not slowing down this year. At the same time, it's crucial for asset owners, project developers, and investors to understand that best performance forecasts often look very different from real-world outcomes, and that gap can lead to some unpleasant surprises. So what are the key factors driving this discrepancy between forecasted and actual best performance? And how do these factors directly impact financial returns? That's exactly what we'll be exploring in today's webinar. So before I introduce our speakers, a few quick notes. This webinar will last about 1 hour, and 2 expert presentations will be followed by a Q&A session. On the right-hand side of your screen, you can see the Q&A chat box. Please use the Q&A chat box to submit any questions you have during the presentations, and I will address these questions at the end of the webinar to the respective speaker. Please note that this webinar is being recorded and will be uploaded on Sinovoltaics' YouTube channel. So if you don't want to miss the newest content updates and stay ahead of the curve, don't forget to subscribe to our channel. So now let me introduce our speakers. So today we have Markus Ovaskainen. Markus, warm welcome. Markus is Sales and Marketing Director at Merus Power. And Markus has been working in the energy storage space since 2017 across R&D, project delivery, and commercial roles. Markus personally commissioned the first megawatt-scale battery energy storage project in Finland. And for the past 4 years, he has led sales and marketing team at Merus Power, where he's been closely involved in building the company's best growth story from its early stages. He holds a master's degree in power electronics, and Merus Power itself is a Finnish technology company specializing in advanced battery energy storage systems and power quality solutions that support grid stability, compliance, and renewable integration. So warm welcome, Markus.
Thank you.
We also have my colleague Ville Julin joining us today. Hi, Ville.
Hello.
Ville is Director of Business Development at Sinovoltaics, and he's an energy storage expert with a master's degree in electrical engineering. He has delivered a high-quality utility-scale battery energy storage projects across the Nordics, the Baltics, Spain, Australia, and Latin America, including Peru and Chile. Ville has extensive experience in early-stage project development, RFQs, and revenue analysis, working closely with both developers and investors. Originally, Ville is from Finland, but now he's based in sunny Barcelona. Before I hand over the virtual microphone, let me quickly introduce Sinovoltaics to those who join our webinars for the first time. So Sinovoltaics is a Dutch-German company providing technical compliance and quality assurance services for BESS and PV sectors. We offer inspections, factory audits, ESG reporting, and traceability audits for utility-scale developers and investors. And with over 15 years of experience, we have already audited more than 350 PV and BESS factories globally, covering all major components such as modules, inverters, transformers, cables, etc. And with boots on the ground in Asia and around the globe, we're your trusted partner for the highest quality renewable energy projects. So without further ado now, let's jump straight to the topic. And we have Markus ready with his presentation.
Thank you, Rasa, and thank you for Sinovoltaics for this great opportunity to talk in this webinar. I hope this will be interesting for everyone listening. I have about 25 minutes, so let's get right into it. Before we jump into the topic, quick introduction to the company. If you're not familiar with Merus Power, we are a Finnish, as Rasa mentioned, we're a Finnish technology company working in power quality and energy storages. We have been working in the market since 2008, and we did deliver 3 out of the 4 first megawatt class projects in Finland when this energy storage boom kind of started. We have our own power electronics manufacturing, based on which we build complete energy storage systems and deliver them EPC style to our customer with all operational services included for the lifetime of the equipment that is made in Finland. Good. To the topic itself, my story, maybe many of you were expecting a technical review of this operational and forecasted performance, but I think it's more interesting to start the story why such discrepancy might exist based on the dynamics of the market. So when I look at the energy storage market, especially in Europe where Merus Power is operating, it is very investor driven. I'd say that about 95% of all the energy storages that are built in Europe are in the end owned by an institutional investor. In many countries, also public companies, energy companies have invested in this, but the market itself and its dynamics, how it has formed, I would say, is very driven by institutional investors. And this means that the performance guarantees, the technical performance guarantees based on which the performance during lifetime is forecasted are simplified to serve financial metrics that then are corresponded to certain revenue streams. These typical performance guarantees that you see in any tender nowadays for energy storage or any technical specification would be the power, charge and discharge power of the energy storage at the point of connection, the round trip efficiency, RTE, I'll be speaking with the abbreviation throughout this webinar, energy capacity of the energy storage at the point of connection, and finally, after the handover of such project or commissioning it, the energy capacity degradation during the lifetime as a function of charge and discharge cycles. Often you talk about, for example, 1 cycle a day, 2 cycle a day, how does the battery degrade as a function of its usage. So using these metrics that are directly related to the available revenue streams, such as the power and energy capacity or the activation time of the energy storage, and then the energy losses that are related to round trip efficiency, typically the investment calculation is made based on these values, and then the energy capacity degradation throughout the lifetime of the investment might limit the available revenue streams that are related to how much energy the energy storage can still offer at year 10 or something. So for this purpose, the optimization when the deals are made is very much around of these values, and the desire for getting these performance values better in a competitive situation is driving the market heavily from my perspective. Since the market is investor driven, I see this difference very clearly because the power quality market that we are also working in is very industry driven and very technical. Typically, our conversation partners there are can be electrical substation managers, maintenance managers, and we go into very deep technical topics when discussing a potential deal. But with energy storages, we might get into technical topics later on in the negotiation phase but everything starts with the financial due to the fundamental nature of this equipment that is when it's operating in electrical markets, it's a money-making machine. Because it's investor driven and institutional investors might have limited technical know-how themselves, and it's not their core business anyway. The risk exposure, so that these performance metrics are actually met, is governed more by warranties, guarantees, termination clauses in contracts than necessarily technical due diligence for the equipment itself. But since this has been the driving force and the market has formed this way, in my opinion, this has maybe reached into weird consequences on the market, because nowadays you can see 10, 15, even 20-year warranties for energy capacity degradation for the batteries or the full energy storage system. And these batteries have first been produced maybe 3 months ago by a company that has been in existence less than 15 years that the warranty is given to. Everybody understands that there's limitation on how well you can forecast the performance for that long period, but since the market is asking for this long warranties in a competitive situation, the suppliers have given them. And often this market works in such a way that there are a number of technology suppliers, battery suppliers that give to these warranties to a system integrator or an EPC contractor that sells an EPC delivery to the buyer that is often an investor. So these guarantees go through an intermediary that still has to interpret them from, for example, from the battery terminals to the point of connection in the network. Since the market is formed way, often only the guarantee, its penalties matter, not what it's physically based on. And my statement here would be that this kind of naturally leads on the market to either the sellers taking uncontrolled risks, which is promising these 15-year guarantees for products that have been in existence for less than 3 months. And since it's a competitive situation, everybody is incentivized to promise a little bit more with a little bit bigger risk. Or you can interpret it in another way. These energy capacity degradation guarantees can be very conservative, and then these guarantees are selling complete air at the moment. But different. It would be different to technically model them heavily on how they work. So because of this nature of the market, where these values are guaranteed with bank bonds, guarantees, termination rights of the customer, they are not necessarily technically vetted as heavily as in more technical markets that we are working in, such as how does the supplier aim to achieve the round-trip efficiency that they promise? What is the power conversion system efficiency in different operation points? For your information, it changes heavily in most of the power conversion systems on the market, since they are based on solar inverters design that are often designed to work with high efficiency in one operation point only. And what electrochemical reasoning is the energy capacity degradation table based on, which is of course hard to find out, since this is often the battery manufacturer's most heavily guarded intellectual property. So when these values are guaranteed by heavy contractual guarantees instead of deep dive into the technology, the idea is to move the risk of the technical performance to the seller's side. But as at the same time, the sellers are incentivized of taking bigger risks, promising more for a very long period of time, you can philosophically think whether what the suppliers are competing with are actual technical performance, or whether they are competing with their risk-taking ability from a contractual point of view. And this would be important for all the buyers to think of. especially since there's a lot of system integrators, EPC contractors on the market who see a big market opportunity. The customers want EPC contracts, and they have been in operation maybe 1 year or less, and have faith that they understand what the guarantees the battery supplier is giving them, and that they can give credible guarantees to the investor. But in my opinion, in the market at the moment, often the buyer nor the system integrator exactly know what are they guaranteeing. In my conclusion, kind of from this, is that how this market market dynamics would work better, in my opinion, is it that at some point the asset owners themselves who own energy storages build more technical competence and in-depth understanding of how these energy storages work in the beginning of their lifetime and how that performance evolves. And then they start relying on their own technical understanding on these technical values and being able to do technical due diligence on them, not only the contractual guarantees, which do not necessarily incentivize being better technically as a product, but promising more and taking bigger risks contractually from the supplier side. This kind of as a starting point to why there might be difference between the operational reality and forecasted performance, where I interpret the forecasted performance to be what is eventually guaranteed in the contract. So pitfalls that I see in this that could be can be avoided, and making better contracts, making the reality more closer to what has been forecasted. That you understand the buyers, sellers, system integrators, they understand the nature of performance guarantees and how they are measured. This charge and discharge power, round trip efficiency, energy capacity. Many of you listeners, many of people operating on this market, I think they have a good intuitive understanding of these. But actually, if you look at the IEC 62933 standard that has clear definitions on them, they are not as intuitive as you might think, and they have very specific way of how they are measured under standard conditions. The first big realization that everybody should have is that all of these, especially round-trip efficiency and energy capacity, are operation point dependent design values. They do not necessarily tell anything about the performance of given equipment. For example, all of the energy storages that we have built, the round-trip efficiency is different. And this is not due to products being different necessarily at all, simply difference between the installed power and energy capacity, a system design, connection point voltage, whether it's in medium voltage or 110 kV. These all affect these values, and therefore comparing, for example, 85% RTE or 87% RTE tells nothing if you don't understand the full system design. So my advice would be to get an understanding of how these values are defined by standard, what do the measurement methods imply, and how these change in different operation conditions. And here I want to do an example regarding round-trip efficiency, so you understand how much philosophy is actually crunched into one number. Round-trip efficiency is typically used in investment calculation as the metric of what are the energy losses of the energy storage, and therefore the lost money based on the energy price on the market. Kind of obvious to and important to include it in the investment calculation. But if you look at how this is actually measured, it defines the worst case point of operation and assumes that you charge and discharge the battery at full power all the time. If you change the charging and discharging power, the RTE always changes to some direction. And if you want to get an accurate measure of the energy losses of an energy storage system, you need to model it much more deeply. RTE is really mainly dependent on the battery's internal losses in different operation points, because if you think, let's say a high voltage connected energy storage system at 110 kV, what all causes losses in the powertrain are transformers, cables that are, as you can imagine, pretty much the same for all suppliers. Power conversion system, where there's some difference in the efficiency, But finally, I'd say 60-70% of all the losses are always caused by the internal heat losses of the battery, which are heavily dependent on the system design, power energy relationship, settings for the battery, HVAC or chillers, and so on. Therefore, one number for RTE doesn't really tell much of the performance on how well the system is designed. To help this, I want to market a little bit. My plan is that Merus Power will publish a round-trip efficiency calculator in our website in February with a blog post where I will discuss this matter a little bit more clearly. But my hope here is to educate the market on how this is actually defined. Often I see that companies do not use the IEC-based standard definition, but make their own definitions, which are creative and show better numbers to those who are not diligently looking into them. Here's an example system of a 110 kV connected energy storage system. Don't be fooled by this shelter building in the right side. This could be battery containers that I'm sure many are used to seeing. This is made for Finnish very low temperature conditions originally. So in this powertrain, there's 110 kV substation, medium voltage switchgear, power conversion system, and batteries. Here the design values are 30 megawatts of charge and discharge power at point of connection, and then 66 megawatt hours of usable energy capacity here at 110 kV. We don't have time to go this in very detail, but kind of just an idea of where the losses of this kind of system in a round trip event take place. You have to consider the cabling losses, transformer losses, auxiliary power use that is heavily dependent on the operation point. If you think of the operation of cooling systems, for example, and therefore the point of connection and the time and even ambient temperature you are measuring the RTE with will heavily influence the outcome. The calculator that we will publish next month will show this in a transparent way. In here you can also see that the biggest losses happen inside of the battery, and it is quite counterintuitive when you charge or discharge the battery energy storage. If you measure the energy flow from the DC terminals of the battery when you're charging it and discharging it, the value is not the same because you always lose some energy with the internal heat losses. When you are charging a battery, you can think of a bucket which you are filling with water that has a hole in the bottom. You measure how much water you are pouring into this bucket, and some goes through the hole. Then you stop pouring water in there, and you close the hole, and then you notice that the water you put in is not the same that you measure that is inside later on when you pour it out of there. Another topic that I wish to discuss is the significance of availability. And since this market is very CapEx price oriented, that incentivizes the suppliers to make compact, simple solutions that do not necessarily last time. But I would like to remind everybody that availability of an energy storage is directly correlated to the bottom line of the revenue streams that you have available every year. So if the system is not built for a long lifetime, if it does not have credible operation and maintenance plan and services available by knowledgeable engineers, it will not last the investment lifetime or even the break-even lifetime in the way that it was planned. In this sense, paying attention into the technical design of the power conversion system equipment, batteries, overall system design, and especially the credibility of the operation and maintenance services have a big importance of what money are you going to get out of the system over the 10-15 years of investment period that you are planning for it. Since energy storages are typically modular systems, they are not one big box that either works or doesn't. The inverters are modular, batteries are individual containers, and in the overall electrical infrastructure design, you can build more modularity as a design idea. When something fails, that typically doesn't mean that you lose all the revenue streams, but but if you have repetitive failures that somebody is always fixing, even if the supplier meets their guaranteed response times, even if they take care of their warranty obligations, that does not mean that you always have the revenue streams planned that you had available. So this design and these decisions of how credible and reliable is the technology that you are using, they are done before the contract is signed, and then you have very little possibility to affect them. Even if you have the investment strategy that you save some money and then you have more money to fix these problems over lifetime, consider that if the availability is low, you're fixing something all the time, somebody is fixing it, cool, but then you're not getting revenue because the system is down all the time. So design choices I already mentioned here, kind of to pinpoint a few: the PCS design, reliability, manufacturer track record, battery design, reliability, and manufacturer track record. Again, if the purchasing strategy is to purchase everything separately, important to understand that these are not Lego blocks that are put together, and you can easily be sure that the system works well together, which is also the reason why the market is favoring EPC supply contracts, where somebody takes full responsibility of the whole system availability. The operation and maintenance services scope, availability promises, spare parts important to consider as design choices, which you often set in the very beginning of the project, that are hard to influence later on if you want to get the performance that you were planning from this system. Last topic that I will kind of try to crunch to leave some time for Ville, the battery cycles, which is Ville will talk about more. Here especially, I think there's a lot of room for interpretation in the current market of how the operation is forecasted, because the battery degradation is simplified. Very complex chemical reactions that are operation point dependent are simplified into few numbers, such as how many cycles a day, and then how does the battery energy capacity evolve over time based on this cycling. It is important to understand that these battery degradation guarantees that you see in the market that are finally put into contract, they are not the physical reality as such ever. It is a mix of simulated technical performance over time for a product that maybe was just launched. It is a mix of risk management. How much do you want to promise based on the income you will get for these promises? Politics, competition in the market. Do you want to take a little bit more risk, give better values than your competitor, or unrealistic values for the 14th and 15th year to get the deal, because nobody will be able to evaluate technically what it is. And here, I think the biggest improvement that the market dynamics could have, that there's a transparent way for everybody to physically model how the batteries degrade in different operation conditions. If you are an investor, a project developer, or a knowledgeable system integrator like us, acquiring some kind of technical capability to evaluate the battery degradation yourself without contractual guarantees, I think would be smart in really knowing how this operation will evolve. Very quickly about the nature of these cycles. When we talk about 1 cycle a day, 2 cycle a day, 365 cycles a year, nobody stops to think about what is the cycle very often. Intuitively, you can easily think that you charge the battery full, you discharge it empty. This is a battery cycle. But that is very rare case in actual commercial use, where you are multi-market optimizing the battery use, and you don't necessarily ever charge the battery completely full or empty. And therefore, when you talk about 2 cycles a day, it's some kind of average over the cumulative energy flow over time. And in reality, each cycle is different, has different power that you are using, different state of charge, evolution, which all affect how the battery realistically degrade. If you would like to simulate the battery degradation and cycling in a physically realistic manner, that would mean that you simulate the actual market operation that you are going to do with the revenue streams that you have, and then this power state of charge evolution charge that you get as an output of such simulation, you would simulate electrochemically to understand how the battery actually degrades. Market still opts for contractual guarantees and simplifications, but I am sure that we will move into this direction because like I said in the beginning of the presentation, either these long-time guarantees that are only based contractually, they are incentivized by risk taking or incentivized by somewhat selling air without anyone even knowing necessarily, because it's hard to forecast for such a long period of time. So what affects this degradation and cycling, rest time between cycles, average state of charge during cycling, average depth of discharge, average ambient temperature, and cooling system settings even for the battery. And therefore, if you are thinking of the difference of forecasted performance and the actual performance of the equipment, you understand how simplified approach it is to talk about 1 cycle a day, 2 cycle a day, and then some guarantees based on that. As a personal experience, I can tell that my experience from the batteries that we have been using in our projects is that the degradation tables have always been way more conservative than the actual degradation is. And I leave it for the Q&A session for you to ask me why. Thank you so much for listening to me and this opportunity for Sinovoltaics. Please stay tuned for this round trip efficiency calculator on our website in February. I will hand it over to Rasa and Ville.
Thank you, Markus. Thank you for this enlightening presentation and explaining why do you have the situations that very often BESS performance forecasting does not meet the reality. So thank you again, Markus. I will now hand over the microphone to my colleague Ville. He will talk about, as Markus already said, battery degradation, because it is also affecting the BESS performance and how to avoid that. So Ville, the floor is yours.
Yeah, thank you, Rasa and Markus, for the very good presentation. So I'll start by sharing my screen. So yeah, I will talk about battery degradation and especially what happens if that is accelerated. It's just one topic that can happen with bad quality control of the batteries. First, I want to show a bit of the latest news from 25. So these topics are quite common to happen in the field. So 1 in 5 BESS projects have experienced issues with efficiency losses, downtime, component failures, increased degradation, and for example, 1 to 2% drop in efficiency translates into millions of lost lifetime revenue per gigawatt installed. One other topic that has been quite often in the news is that there has been commissioning delays that greatly impact the ROI of the project, because as we all know, battery industry and the market is very, very new, so the projects need to be on time, otherwise they risk, for example, saturation. And also there has been a lot of performance shortfalls on the site acceptance tests. So when the project is being, let's say, started, it hasn't reached the nameplate capacity of the contractual values. So that already exposes a big quality gap in the industry that has not been caught earlier. And with factory acceptance testing, and other topics, we can try to mitigate these risks. So first of all, what kind of financial impacts does the accelerated degradation of your batteries do? So first of all, you have less energy to trade, and still the auxiliary consumption will stay the same, meaning that of course you will have less revenues. Also, some of the markets are based on a promise on a certain energy capacity or power. So your battery, if it degrades faster, it might not be able to participate on those markets. Or if you have a contractual, let's say, power or energy that you need to supply, then you need to pay penalties for not reaching that. Then, since the batteries are degrading faster and you still want to keep on using the asset, you need to augment your site, and you need to inject capital faster than you thought. So not just buying the equipment, but also having people to install it and do testing. And of course, during that time, it's also not in the market producing income. And lately, especially in Nordics, there's been discussions of a lot of that batteries are going to be done with co-located wind and solar. And in those cases, the idea often is that the extra production that these wind or solar assets has will be stored in the battery and then released later on when the energy prices are higher. So if your battery doesn't hold the capacity or have the storage capacity that was promised, then there will be more curtailment of these production assets. And also you cannot shift the energy production that well into expensive hours. So once again, decreasing the revenue of the co-located asset. Then how can we actually avoid this kind of accelerated degradation? So Markus was very well explaining about what can be done on the contract side. So having these guarantees, learning actually how the system is operating, putting a lot of clauses and getting product warranties. Then what you can do is audit or do your technical due diligence on these suppliers, figure out what's the best one by doing, for example, audits. Then on the factory floor, you can do production monitoring and factory acceptance testing. That's something that I will focus on today. And then once the equipment has reached your site, you can do site acceptance testing to really check if the energy capacity, for example, is what it is. And then on the operational side, of course, you need to do monitoring for the system and then understand how the asset is performing and optimizing based on the markets and degradation that you see. So if we think about on the manufacturing side, everything starts from the battery cells. So there's many topics that impact the degradation of the batteries, and most important one is the temperature. So the more heat there will be, the faster the battery will degrade. And internal resistance of cells is one good indicator of this. So you can have two cells that have the same initial energy capacity, but the different internal resistance. And once you start using these cells within the modules, containers, the ones that heat up more will degrade also faster. And since you're most likely to buy the battery containers from an integration factory, be it the same manufacturer as the cells or a third-party company buying those cells from different manufacturers and then integrating them into modules and racks in their factory, it's very important to know how this kind of incoming quality control of the cells is done at the factory and what kind of data is being stored and collected, and to really get access to that data to be verified. Because once the cells are integrated into modules and later to racks, it's very difficult to do any changes on that side anymore. So also on the contractual side, one thing to improve is to have like acceptance limits for the quality of these cells. So having, for example, limits for the internal resistance, what kind of voltage differences they are, and acceptance limits, temperature differences, and so on. So on the manufacturing side, when we do production monitoring, this is a very common thing to do in the PV industry, but we are just recently starting with our first projects with batteries. So first thing to do is to check that in the factory floor they actually follow the standard operating procedures, which is kind of like saying that there's a recipe for making a cake, and then how does the chef follow that recipe. So the same thing in the factory floor. There's how are the machines being calibrated, how often are they maintained, in what kind of conditions are the raw materials stored, temperature, humidity, for example, what kind of equipment are the personnel using, and so on. And the other part is to verify that your container is being built with the correct bill of materials. So first of all, that only cells from one supplier are used, and there's not being any shortcuts on using cheaper components, let's say cables or connectors, and also that the components used in your container are also verified in your region. So for example, you can have a cooling system in a container, and it can be you can have a different one for the US market and for the European market. And recently I saw a good example of a PV system in Europe. The oldest one, it's 35 years in operation, and there was the solar panels had a few different versions. So the BOM bill of materials was slightly different, but on those 35 years of operation, you could really see the performance difference between those different panels with bill of materials. All right, and the second thing to do at the factory once the container has reached the end of the production line is to do factory acceptance testing. And that often includes visual inspections, mechanical, electrical testing, performance testing, safety testing, and let's say spray testing. And to really focus on the underperformance of the container, performance test is the most crucial one. And these kind of performance tests, they often culminate in a full charge-discharge cycle to verify that the energy capacity and round-trip efficiency of the container is what it should be. But the manufacturers, they leave a buffer on this contractual capacity, meaning that if you buy a 5 megawatt-hour container, for example, you can have a few modules inside of the container that are not working as they should, but still on an overall level, the container will pass. So it will comply with the energy capacity, power, voltage of the container, but it leaves this kind of risk of having these modules and racks that are performing suboptimally. So that's the reason why we have developed a software called BESS. So there we can dig inside of the container to see for each and every module and rack, how are they performing against their specifications. So if those don't comply, then those modules can be replaced at the factory, and that's a way to save a lot of time and headaches at the site acceptance testing. And to end, I have a couple or some statistics. So last year we did over 500 megawatt hours of analysis with this essential software, and these results are only from the tier one suppliers, and in 66% of our projects they all had some issues, and most of these issues are actually related to thermal management, higher temperatures, and big differences between these modules. And here I have one example. So these are temperature differences within the modules inside of the container. So each of these modules represents, each of these columns represent a module, and then the color coding means from what rack is that from. So you can see that some of the cells, the modules, the temperature differences were too high, so they were considered to be the issue here. And you can see that there's a difference between the modules within a rack, meaning that some modules heat up more than the others. So most likely the ones that are in the center or in the top of the rack will heat up faster and more. And then you can also see that also the racks and the temperatures within those modules are dependent on what rack is it. So most likely the two racks that are having the issue, they are most likely in the center of the container, because there the heat will have more difficulties to dissipate than if the racks are on the end of the container, for example. And I see that there's two possible root causes for this. So the first one being the difference in quality, for example, the internal resistance that heats up the cells and then the modules. And the second one is the cooling system design and the equipment used. So since every manufacturer is using their own design for the container, the layout, the cooling system, the heat will be differently dissipated, and also the equipment used is different, so that will also impact how they can cool the system. So that's it for my part, and I'm looking into the Q&A session.
Thank you, Will. Markus, I invite you to join us on the stage for the Q&A session. The Q&A chat box have been booming since the presentation started. So we received, I think, a record amount of questions, and we only have 10 minutes left. So all the questions that we are not able to answer live, we will address them via email. So let's start with the question to you, Markus. Are suppliers giving longer warranties in Europe due to its colder climate than warranties in warmer climates like the Middle East, Asia? Does colder climate play a role in lower battery degradation, resulting in longer warranties?
I don't think that the warranties are necessarily any longer. I assume that the warranty length similar demand everywhere, but there are special applications related to the thermal management here, because I don't think most battery manufacturers, they don't think that their number one and top priority market is necessarily Finland or Sweden only, but they build a product that can be shipped globally, and therefore they don't take extreme temperatures like minus 50 degrees that might be required in the north part of Finland into account, and therefore this might lead to discussion or modifications to the battery product, or such as in my presentation, building a shelter building to provide a higher temperature. But the warranty lengths, I don't think they vary based on this.
Thank you. Question from Martin, again for you, Markus, and I guess you can keep your microphone on because there are plenty of questions for you. How do you rate O&M or integrator guarantees backed by international insurance companies?
I can't comment on these backings of international insurance companies, but in general, we of course are a system integrator and EPC company ourselves, and our own guarantees are as truthful as we know them to be based on the battery guarantees. But when we discuss with various battery suppliers, I see variants, different interpretations, different specifications on how these guarantees are framed. And navigating this, even though I've worked with energy storage market for 7 years, I think it's still not easy. And if it's not easy for me after seeing NMC, LFP batteries, multiple suppliers, I can only think from the customer perspective how much of a mess it might seem.
Okay, thank you. A question from Stephanie. Again to you, Markus, and that's a long one. So you mentioned that there are limitations of the most commonly used guaranteed performance metrics like RTE. How then to simulate and forecast long-term operations at investment phase without more advanced data provided by the BESS OEMs? It seems only them have comprehensive model down to cell level to appropriately model operations linked to degradation.
It is true that they have the maybe best quality information on cell level, but they are not only companies now working within the energy storage sphere who do this kind of modeling on a physical level. I do not want to advertise any particular companies, but for example, in Germany, I know that there are engineering companies whose business is to give a second opinion, whose business is to collect different cells, test them, and provide physical data on this modeling with related to all of these performance metrics. And my forecast would be that this business will boom much more after the market notices that these contractual guarantees are not enough and they want to see what's behind the numbers.
Thank you, Markus. Now we have a question to you, Ville. You mentioned some of the practices, how to ensure the best quality, but what would be your advice? Like a question from Beryl, simply, what is the best practice to ensure highest quality BESS? And what are the biggest risks for skipping quality control in BESS procurement?
Yeah, good question. So first, of course, is the supplier selection. You can have companies that do both, so they manufacture the cells and they also integrate the cells into modules and have their own equipment for everything. So those tend to be a safer choice. And then risks of skipping quality control, well, there's a bunch of examples. So one was this, let's say, the degradation. So you can have, if you don't do proper quality control, you can end up having modules that are not performing that well, and then they impact the whole overall operation of the container. It will degrade faster, but also what we have seen a lot is, for example, the fire safety system not working. That's one of the most common issues that we have, and of course, if that fails during operation, it's a huge bill to pay. And there's plenty of other things. You can have the, for example, coating of the container is not proper, so then it will rust and water will ingress the the container later and affecting the power electronics, for example. So yeah, my best advice then is to, if you haven't chosen a supplier yet, maybe do an audit for them, check their premises, and then focus on the quality control. Some of the factories only allow you to check like a small percentage of those containers, but we really recommend to check as many as possible, because manufacturing batteries is still much more, let's say, artisan work compared to manufacturing panels.
Thank you, Ville. And another question to you is from Fabio. Is Bessential FAT procedure accepted and enabled by all major suppliers?
We haven't done it to all of the major ones, but to many of the major ones. But it's, let's say, a progress that we show that we show up in these factories many times, and then they start understanding what we are actually doing with the data. We are not trying to steal their IP, these kind of things. But it's coming more accepted every day that we speak.
Okay, thank you. Question from Sanjay to you, Markus. How many cycle of operation is practically possible for BESS system in 24 hours? Nowadays, most of the utilities are asking for 2 cycles per day, but something more than that is used anywhere, say 3 or 4.
I can speak of the physical limitations. This relates to first of all, to the energy capacity. So if you think of you have a 2-hour or 4-hour batteries, charging 2-hour battery, when you charge and discharge it, that already takes at the very least 4 hours. In practice, closer to 5-6 hours because of the losses that are incurred on the way. So that limits how much time do you have to do these cycles on 24 hours. But for physical limitations, I do not know. I have not seen cases that are really moving forward to investment where the cycle number would be higher than 2, I believe, because the risks and the relationship of the profit that you could get from higher average cycling compared to the risk of the battery degrading fast simply do not match in any market. This is my experience.
Okay, thank you, Markus. Another one for you from David. Based on your experience and considering all boundary conditions and operational variables, is it reasonable to expect that a BESS, if managed correctly, will retain around 70% of its energy capacity after approximately 4,500-5,000 full charge-discharge cycles?
Here I'm going to give a simple answer and say yes. It will depend on what kind of cycles these are, but here I'm going to simply say yes.
Okay, thank you. Another one for you, Ville. From JB Rayesh, is fixed fire protection equipment also tested as part of FAT? If so, what kind of tests are involved?
Yeah, so with fixed fire protection, I imagine that the equipment that is put inside the container. So yes, we test that, and normally the most important tests are to verify that actually the sensors are working. So we have, for example, a device that can emit smoke and heat to really trigger these sensors, and then seeing if, first of all, if the system reacts and how is that message then conveyed to the BMS. So that's kind of the main thing to do there. And sometimes these sensors don't work, sometimes the cables are disconnected, for example.
Okay, thanks a lot, Ville. And one last question to you, Markus, as I'm conscious of time. What are the biggest challenges for Merus Power in terms of the current market situation?
Oh, that is a great question. I would say that it is actually related to the topic that I was talking about today. So I see that give better back guarantees, accept higher penalties, accept termination of contract if everything is not to our pleasure. And I can see that many competitive companies, especially with a short-term vision and wanting to win deals quickly, are giving into these demands, which takes to the market to the direction that I was giving. We want to be a reliable and a reputable EPC company and system integrator and show that all of our systems really work and for a long period of time. And they have. We have references to show that. But within this crunch of demanding more and having to give back-to-back guarantees for very long time periods that nobody really knows about, that would be the biggest challenge.
Okay, thank you, Markus. Thank you, Ville, both of you, for really great presentations. We had more than 200 people joining us live today. I think that's a really good start for the webinar this year. So I will close this webinar now. Please keep an eye on the upcoming webinars from Sinovoltaics side, and all the questions that we were not able to answer during this webinar, we will follow up on them in a written manner. So thank you, and see you soon in the Sinovoltaics webinars.
Thank you. Bye bye.
Thank you, everybody. Thank you, Rasa. Bye bye.